So here we are, Math 15, Lesson 6, Factoring by Grouping. This is on page 22 of your note package. So, as a rule, the factoring by grouping method should be used when you have a polynomial that has 4 terms. And 4 terms that you cannot combine as like terms to reduce to like a trinomial, okay? Now, there's some steps you should follow. As always, we always factor out a GCF first. And also be sure to factor out negatives if the leading coefficient is negative. And don't forget to include that GCF as in your final answer, okay? Determine the GCF of only the first 2 terms and factors. So this is after you've taken out the GCF of the whole thing. Then you look at the first 2 terms. So we have 4 terms. So if we have like A plus B plus C plus D, then what you're going to do is you're going to factor out from the first 2 and then from the last 2. So that's what this is referring to. The GCF of only the first 2 terms and factor, and then of only the last 2 terms and factor. If there's not a GCF, like if you do it and you go, well, there's nothing, then you take out a plus 1, okay? After you do that, hopefully, if all went well, factor the common binomials out. If the 2 remaining binomials do not match, then you might have to rearrange and start from the beginning. Optional, you can check your work by expanding using FOIL of the 2 binomial factors and see what happens, okay? So let's see what happens in this example. We have 3x plus 7y minus 21 plus xy. Now, when we look at this, we might want to rearrange. And we are going to rearrange. We're going to, because the thing is that 3x and 7y have no common factors, and minus 21 and minus xy outside of negative 1, they don't have any common factors. But if I look at my 3x and my xy at the end, they do have a common factor. So I'm just going to rearrange so that I have 3x minus xy first and 7y minus 21 second. Then I'm going to factor out. Yeah. And I've got to talk about the answer because it's wrong here. It's like, what the heck? There's also okay, yeah, let me work through this. We're missing a term, that's why. I'm like going, that's not right, okay? So anyways, I rearrange the 3x and the minus xy. I can divide out an x, and I get 3 minus y. The 7y minus 21, I can factor out a 7, and I get a 7 times y minus 3. So what we notice is y minus 3 and 3 minus y are very similar, or are the same, right? This is a very bad example, I'm sorry. Because they're similar, but we had to divide by a negative so I could get them in the right order, okay? Basically, I get 3 minus y times x minus 7. I FOIL, and when I FOIL that, I get this. Let's do some examples. That's not a good example. I don't like that one, so I'm sorry. It's going to be interesting when I teach it live. Okay, so let's explore this. Okay. So looking at this first example. 10x squared plus 5x plus 4x plus 2. Now, technically, I could combine my like terms and just factor my trinomials, but I can also, I'm going to follow it doing this method. Okay, I put brackets around the first 2 and brackets around the second 2. Then I look at my first two terms. So 10x squared plus 5x, I can take out a 5x. And I'll get 2x plus 1. And for 4x plus 2, I can take out a 2, and I'll get 2x plus 1. Now, what I see there when I'm looking at it is I see that I have the same binomial in the bracket. So basically, 2x plus 1 and 2x plus 1 is a factor of both of those. So I'm going to factor out the 2x plus 1. Now the remainder is what the other bracket will be. So, sorry. I want to make it blue so you can see what it matches. Okay? So this would be 5. Pen problems. This will be 5x plus 2. 2x plus 1 times 5x plus 2. Now, how do we check? Well, we can FOIL. So let's FOIL this. And I'll get 10x squared plus 4x plus 5x plus 2. Now, these are the same. They're just in the opposite order of what they were at the beginning, but they're the same values. Now, you could have also combined like terms and tried to factor the trinomial. The only problem is it's got that factor in front of the 10, so you can't use the process we've been doing so far because it's a complex trinomial. Let's do some more. All right, here. So brackets around, and I'm going to change this to plus a negative x. There's a reason for it. Okay. So here, 2x squared plus 6x. I'm going to factor out a 2x. I'm going to get x plus 3. And here, negative x minus 3. I'm going to factor out a negative 1. So I'll get positive x plus 3. I do that because I want this to be the same as that. Okay? Now it is. So from that, I've got my x plus 3, which is a factor of both of them, and then the remainder is what's going to go in the second bracket, 2x minus 1. Okay? And again, you can FOIL and see if you get the same answer. Okay? Let's do the next one. Well, this is a big mess, right? There's no common terms, so we'll put our brackets in. I'm going to change this to plus and negative because it makes it better for factoring. So here, 2a squared minus 2ab, I can take out a 2a. So I get a minus b. Here, negative ab squared plus b cubed, I can take out a negative b squared, and I'll get a minus b. Now looking at this, common, yay! So that would be my first bracket, a minus b. And then looking here, whoosh, that's my second bracket, which will be 2a minus b squared. And again, if you want to check it, check using FOIL. Okay? Alrighty, next one. 3y cubed plus 12y squared plus y plus 4. So, brackets, whoosh, whoosh, whoosh. Okay, let's do some factoring. 3y squared and 12y squared, 3y cubed and 12y squared. I can take out a 3y squared. I get a y plus 4. Now, here's one of those situations. There's nothing I can take out. There's no common factor. So if there's no common factor, then you take out a 1, okay? 1. So plus 1, y plus 4. And I need it there because if I don't have it there, it's going to mess up the next step. So this is the same. So that will be y plus 4. And then this and this will be my second bracket. So that will be 3y squared plus 1. Now, if you didn't do that plus 1, you would just get 3y squared, and it wouldn't work. Okay, it wouldn't get you the right answer. So you have to put in the 1. It's kind of like a placeholder, but it actually mathematically is necessary. Okay, let's do some more. Okay, here I'm changing it to a plus or minus. Okay, so let's do some factoring. So I'm going to take out a negative x squared. So I'll get x minus 5. And here I'm going to take out a negative 3. And I'll get x minus 5. See, taking out that negative, I get the same thing. I get what I need in the brackets because I get x minus 5 and x minus 5. So x minus 5 is, I'm factoring it out. And then the other term, negative x squared minus 3. Now, let's write that. Oops, that's not what I want. I want this. Negative x squared minus 3. But I don't like having that negative sign in there, right? So I'm going to factor out a negative. So it's going to be, I should have done it first, is what I should have done. So I'll factor out a negative, and I get x plus 3, and then times the x minus 5. Doesn't matter the order. I should have divided out the negative first. Okay, just because I don't want to have it in the bracket there, right? Like, it's just ugly, right? So let's get rid of it. Okay. Well, we don't get rid of it. We just put it somewhere else. Now, here's an interesting one. These are similar but different, right? So if I factor out a negative 1 from this bracket, I can change the signs. So what do I mean by that? Well, if I factor out a negative 1, so change this to positive, then this becomes negative 2b, and that becomes positive 3a. And then they're the same expression. Plus 9, 3a minus 2b, because that's what I want. So just be aware of that you might have some times where if they're the right terms, but they're the opposite signs, just factor out a negative. And that's what I did there. Now when we do this, we'll get 3a minus 2b times 5x plus 9. Okay, just to kind of think about what's happening there. If I have 2b minus 3a, if I divide out a negative 1, this becomes negative 2b plus 3a. So it's negative 3a minus 2b. Okay, so this is just factoring out a negative 1. Okay, and that just changes the order. Okay, now these are all practicing with these factoring by grouping. It's a very specific types of factoring. It's just a strategy that we use. We use it less than factoring trinomials, but it's good for you for the factoring practice. And so have fun. And then we're going to look at factoring trinomials. Now remember, I said on your test, I'm actually not going to focus on the harder trinomials. There will be some factoring by grouping, but it's important for us to take a look at it. So next course, when you do 10C, it doesn't totally surprise you, but I'm not actually going to assess you on it in Math 10 and Math 15. I'm just going to show it to you, have you somewhat familiar with it, give you some time to practice with it. And then so that when you do your math